Hi, my name is Samantha, and today we're going to be doing maximum subarray. This problem is seen in the Amazon, Apple, and Bloomberg collections, and I'm pretty sure it's also part of the Blind 75. And the question goes as follows. You are given an array, and you have to find the largest subarray's sum within that array. And a subarray is any array within this array. It could be a size of 1, it could be the entire array, but it has to be continuous, meaning they have to be consecutive. And so if we look at the first example, the largest subarray sum is 6, and they get it from these 4 values. When you add them up, it gives us the greatest value that we have seen in the array. And obviously you can tell that if we were to include the -5, which is to the right, then that would make a sum of 1, so that's not our greatest sum. And the same goes for the left. If we were to add the -3, that would give us a sum of 3. So that's why we include this question. And then it's just important to look at example 2, which is that if we only have one value, which we don't know the size of the array, but if the size of the array is 1, then that is our maximum sum. That's what we have. And so we're gonna go over and draw this out before we actually solve it. And so the example 2 is important to note because when we do this question, we're going to be keeping track of the current path sum that we are at and also the greatest path sum that we have ever encountered. So A stands for answered, and that stands for the greatest path sum that we have ever seen, period. And then C stands for current. It's our current sum. And so when we're at our first iteration, all we know is that the array is of this size. We don't know anything else. We're like looking at this in a small scope such that this index is all we know. So if that's the case, then our current sum is -2, and our greatest sum that we have ever encountered also by default has to be -2. And so now when we get to the 1, we're gonna look, and now in our mini scope, we think that our array is of size 2. It's the -2 and the 1. And when we get to this 1, and again, a subarray can be a size of 1, we say, is the 1 alone a greater sum than if we were to add this current index that we're at to our previous sum? So 1 alone is greater than 1 plus -2. So we're gonna say, okay, forget everything to the left of this 1. We don't care about it because it doesn't help our greatest sum. So we're going to update that our current sum is now 1. And now because our answer needs to be the greatest sum that we have ever seen, this also becomes a 1. And now we look at the -3 and we say, is 3 alone, if we were to take this as an individual, is it greater than if we were to add it to what is to our left or whatever we have previously calculated on our left? In our case, the 3 alone is less than. So we are going to want to add the -3 plus our current sum that we have, which is going to give us a -2. And then this answer is going to stay as a 1 because 1 is still the greatest that we've ever seen. Now we look at the 4 and we say, is 4 alone greater than 4 plus our current sum? It is. So we're going to update our current sum to 4, meaning that we don't care about everything to our left. In this sub array of just these integers, the 4 is the greatest. So we update it, and now we update our answer. 4 is the greatest we have ever seen. The same kind of goes as we've been doing. This is going to become a 3 because the -1 alone is less than when we add it. This stays as a 4. This will become a 5. This will become a 5 as well. This will become a 6. That's where we get our answer. This gets updated to a 6. And then, again, if we were to do 6 plus -5, it's a 1 as opposed to the -5 alone. So this is a 1. This stays as a 6. And then this becomes a 5. And this remains as a 6. So that's how we get our answer. And it's important to note that if this was a, say that this was a -4 here, and then we had a 10. Then when we got to the end of our array, this 10 would be our maximum path that we saw. But that's basically just the algorithm and how we do it. And so now when we code, we are going to keep track of those two variables that we discussed. So we'll have a cur sum, and that has to be equal to nums at 0, as we saw. It has to be equal to something. And then we have our ants, which is also equal to nums at 0. And so we're going to iterate through our array starting at 1, because we already dealt with that. And at the end, we are going to just return ants. And so that way, if the case is in example 2, our answer is already set to 1, and we'll return it because it just won't go through this for loop. So we are going to say, what was that check that we were doing? We were saying if nums at I is greater than nums at I plus our current sum, right? That was our check. So what are we going to do? We're going to drop everything to our left because we don't care about it. It doesn't help. So we're going to update our current sum to be nums at I. But if this case is not true, then we're going to say current sum plus equals nums at I, meaning that we want it to contribute to our maximum path. And then no matter what, as we saw, it doesn't matter what we did with our current sum, we still had to, do this check for our answer. So what we do is we say answer is equal to the maximum of our current answer and our current sum. And that is how you solve this problem. It's done in O of n time because we only go through the array once. N is the number of elements in the array. So we just go through the array, and that is how you solve it. You have to go through the entire array. And if we hit submit, that is how you do this problem. Thanks for watching.